25. Sodium carbonate dissolved in ethanol to give 2.5 molar solution. Calculate the molality of the solution if the density of solution is 1.43 gram per milliliter. Density of solution is mass of solution divided by volume of solution. So from here, you already know the molarity. So you need to know the molality. You are given the density. So from here, so the mole is 2.5 mole dissolved in 1 liter of solution. Because 2.5 molarity means 2.5 mole in 1 liter solution. So we already know the solution have 1 liter 1 liter volume. So molality for 1 liter volume. What is the mass? So the mass is 1430 gram, mass of solution. So the mass of solution is 1430. So then we can identify the mass of solute. Mass of solute, change the molarity to mole and the mole to mass. Molarity change to mole, we will get 2.5 mole, and the mole change to mass 265 gram mass. So this is mass of solute. Mass of solute, mass of solution. So from the mass of solute, we can identify the mass of solvent. So 1430 minus 265. Mass of solvent is 1165 gram. Change to kilogram, 1.165 kilogram. This is the mass of solvent. So molarity is mole divided by mass of solvent in kilogram. So that is 2.15 molar. 2.15 molar. 2.15 molar. Number 26, 50 milliliter of saturated solution contain 52% NaOH by weight, by mass lah tu, with a density 1.48 gram per milliliter used to prepare 0.5 molar solution. Determine the initial concentration of NaOH used and the amount of water required to prepare of 0.1 molar solution. Okay. Dalam soalan ni ada beberapa lapis. Ini kita kena pecahkan lah. 50 ml saturated solution in NaOH contain 52% of NaOH by weight with a density 1.48 gram per milliliter used. Okay, so from here, from the density, we have density 1.48 gram per milliliter, and you are given the volume of solution is 50 milliliter. So from here we can get the mass of solution is 64 gram solution. So the percentage by mass given is 52%. So from here, mass of NaOH 52%, in the solution have 74 gram. So if 52% by mass of 64 gram is 38.848 gram of solute. This is solute, mass of solute. Okay, mass of solute 38.48 gram. So from the solute, change to number of mole, 0.962 mole. So what is the initial concentration? So this is the mole in the solution. Okay. What is the initial concentration of NaOH from the stock solution? So initial concentration, so molarity is mole over volume. So from volume, from mole 0.962 divide by 0.005 liter, because the solution have 50 milliliter, change to liter, 0.962 mole divided by 0.05 liter, 19.24 molar. Okay, this is the molarity at initial. How much water required to prepare 0.5 molar NaOH? This is dilution process. M1 Mi initial divide M final must insert the formula we need the final volume here. So the volume final is 9.62 liter or 9642 milliliter. Amount of water required to prepare 0.1 molar. So this we can answer in this question or in liter or in milliliter, either one, because the question not state what unit you need to use. So you can let it in milliliter. 9620 milliliter is okay, no need to change to liter. So amount of water required is 9620 minus 50 milliliter, because 50 milliliter volume at first is 50 milliliter. You need to minus the 50 milliliter because 50 milliliter are already there. The question asks how much water needed to be added, right? How much water required to change the molarity to become 0.1 molar. So 9620 milliliter is the volume already in the solution. So the 50 milliliter is already have before. So you need to minus 50 milliliter to get the exact value of how much water is added. So the last answer, final answer is 9570 milliliter. Okay, the answer here before with 50 ml. So you need to minus 50 ml at first, because the question asks how much needed to add. Berapa banyak lagi nak kena tambah. Ini jawapan yang dia bagi dalam soalan ni, volume yang dah sedia ada lah. So volume tu kena tolak dulu 50 ml yang awal, barulah tahu berapa banyak yang dah kita tambah kan. 9570 lah. Okay, tu je.